So, we're going to be going through this very tricky looking integral. Now, if you haven't met integrals like this and you just want to give it a go, your first inkling might be to take this whole thing as a substitution. So 1 plus x squared, differentiate it as you do, and then find a way to get dx on its own. So it's du over 2x equals dx. And then you go from there. You might make a second substitution here, and then you're gonna work your substitutions backwards, and it's just a mess. So we're actually going to employ a special kind of substitution. Now, it might look a bit weird, but once you see it in action, it will sort of pan out. So we're actually going to let x equal tan of theta. Now, this might look very strange, but trust me on the process, we'll get to solving this integral. So differentiating, we get dx by d theta equals tan goes to sec squared. So multiplied by d theta, you get dx equals sec squared theta d theta. Now, if I just rewrite this integral using our new information, 1 over 1 plus x, which is tan theta squared, so tan squared theta, multiplied by sec squared theta d theta. Now, this is where some trigonometric identities come into play, so I'll do it in blue. The one that we're looking for is when you divide this whole thing by... ooh, I forget now. By cosine squared theta. That's what it was. So, divided by cosine squared theta, you get sine squared theta over cosine squared theta. That's cosine squared theta over cosine squared theta equals 1 over cosine squared theta. Now, this will cancel and just give you 1. So you end up with 1 over cosine squared, which is sec squared, equaling 1 plus sine over cosine is tan. So, this 1 plus tan theta business, we can separate and just write as sec squared theta times sec squared theta here, d theta. And again, these just cancel. And so what we're actually left with, weirdly, is just the integral of d theta, which is theta plus c. Now, our integral is in terms of x. So we look back at our substitution. X equals tan theta. So this implies theta is tan inverse x. So, our final answer, the integral of 1 over 1 plus x squared dx equals tan inverse x plus c.